Yes, please.
Okay, so thank you very much for inviting me to this conference. That's not the first time. Is that the third or second time? I don't remember. So I'm Christian Mercat from Lyon in France, and I'm going to talk about a project that we've been doing about computational thinking. Okay, so let's first introduce myself. So I'm the adjoint director of the Institute for Research on Math Education, IREM, and this is happening in Lyon, where we have several projects, European projects, such as Colette on computational thinking with various partners in Europe. Okay, so and Lyon is a very nice place to do science, especially science around engineering, teaching mathematics to the engineers, for example. That's one of my main topics. And I do train math teachers. So Lyon, Chemnitz will be the capital for culture next year, but this year is near Lyon in Villeurbanne. And so we have a wealth of very interesting schools, engineering schools especially. And I'm here standing in the Maison des Mathématiques et de l'Informatique, House of Mathematics and Computer Science here in Lyon, where we do interesting things such as summer camps for mathematicians and young mathematicians. And this is due especially to the fact that we have a very vivid team around the popularization of mathematics led by Etienne Gis and Aurélien Alvarez. And they did these very nice movies that I really urge you to see, which is Chaos dash math and dimensions. Okay, and so here we have in this very special place where I stand, we have things on artificial intelligence, but actually unplugged artificial intelligence. That's very interesting to understand what is a Bayesian network, just doing things with your hands. Okay, you don't have to go full-fledged computer to understand what artificial intelligence is about. Okay, so the main point of this talk is going to be centered on teachers actually, and show what shall we teach? What shall we teach in a world of artificial intelligence? How does artificial intelligence change the way we teach? And the answer I give is well, we ought to make very clear what is computational thinking. Okay, and this project Colette is about that. Okay, so what to teach in a world of data? Well, we have to teach our students these skills, how to abstract, how to decompose a problem, how to generalize, how to automatize the task, and how to debug a program that we plan to do. Okay, so we have to understand our students. Okay, our students, they are born with these absolutely magic wands that they have in their pockets, that all of us have in our pocket, and that most of them, they don't understand. Okay, and they don't understand how it works, and they don't relate to it with a scientific mind, and we shall definitely improve that. Okay, so especially in the world where this magic wand is supposed to be intelligent. Okay, it's artificially intelligence. How are we going to teach students who think that they don't need to be intelligent because their device, their magic wand in their pocket, is going to be more intelligent, smarter than they actually are? Okay, this is a complete how would I say, defeat of teaching. Okay, so if we take at this level, okay, so some of us teachers think that this is a defeat of intelligence. Artificial intelligence is the end of teaching. Of course, I'm not of that kind. Okay, because that we absolutely know that there is a very big difference between correlation and causation, and it's pretty easy to fool OpenAI, for example, ChatGPT, into well, let's say, when did Urna discover the America? Well, it's going to give an answer, okay, and mistaking Urna with Columbus or things like that. We do know that, okay, but the students, they don't, okay, they don't understand that. They think that there is some magical trick up there, okay. So we have to have a much more scientific view on what is capable of the machine that they have in their pockets, okay. So we are as well faced with a certain way of teachers that don't change, okay. So this is a very nice, in my view, a way of representing different means of conveying exactly the same content, okay. We just adapt and use the evolution of technology just to give the same content. But of course, in science, it is not the case, especially in mathematics. I'm a mathematician, so we have new tools to make mathematics more, not a little bit less abstract, okay, not less difficult. Mathematics is as difficult as it used to be, but now we may facilitate the way that students could make new images, new pictures in their head of the abstract concepts, using, for example, GeoGebra, or in France we have Cabri Geometer, which is a very old lady, because it was the first version was in 1984. Can you believe that? 1984, but it's now really a tool which is very, very interesting, and I urge you to have a look at it. So that's Cabri Geometer. And so that these tools, they make mathematics more tactile somehow. You can touch mathematics, okay, and you can make use of lots of data using mathematics. And this is, for example, we had lots of data flowing to us in a very anxious way with these COVID cases, and you may relate to that, and this will maybe decrease the anxiety relating to this data when you make sense out of it. For example, making plots or seeding differential equations in order to maybe predict what is going to happen. Okay, so science and mathematics is a language that allows us to describe reality, okay, to model reality. What is modeling? Modeling is describing, first to objectify a situation, okay, so that we can share a piece of reality and have the same language to talk to one another on this same reality, to objectify things. And modeling is a bit more than that, because I mean we have to say what is important, what are the variables that we want to talk about, and then how they correlate. Okay, and this allows us to predict what is going to happen, what might happen in our model, and then comparing that with a prediction with the actual reality, maybe act on this reality in order to change it and to adapt to how things are going. Okay, so once again, in order to do that, in order to model reality and to open a scientific eye on your surrounding, you have to abstract, decompose, generalize, automatize, and debug. And these are the core competencies in this computational thinking. Okay, so computational thinking, I'm going to review what it is. So in these 6 competencies, so you have to think algorithmically, to abstract, to generalize, to decompose, automatize, and debug. So think algorithmically is come to a goal through clearly defined steps, and this is a comics by ISCSET between the difference of by differentiation. You have a rule, which is an algorithm. You begin with an algebraic expression, and then you could derive it. And integrating, that is to say, doing the reverse. There is just some heuristics associated to that, but not an algorithm. Okay, so abstraction. To abstract is to choose the focus of what is important and what is not important, to reduce the complexity of a situation by just focusing, blurring unnecessary details, and as well replacing the objects of the real world with models, with abstract ones. Okay, so for example, this is not a pipe. Okay, this is not a pipe because that means this is la trahison des images of Margaret tells you that when you paint something, then you design something. This is a sign. This is not the thing. It's a sign of the thing. Okay, and to make the difference between language, this is visual language, and the thing that it depicts. Okay, so abstraction is super important. Generalizing is as well a very core competency where you have to see a structure behind a real phenomenon, and understanding one phenomenon as among all the possible different way it could have been, as an instance of a general set of problems. Okay, and as well, in order to do that, you have to recognize patterns, okay, of similar problems, and maybe putting one specific problem inside a family of different problems might help you to solve this general problem and then this more specific problem. So to decompose is the divide and conquer strategy, where you can, for example, if you have a polynomial, then you may break it into products, and then to find the roots of the polynomial, where you may work on the different sub items of this product. Okay, and to automatize is to explain the problem to a machine. Okay, that's really the great difference between algorithmic thinking and really computational thinking, which is where you use the power of computers to make quickly repetitive tasks. Okay, and be efficient to solve efficiently a problem. And this way you have to structure the data. Okay, you have to say, okay, I might have some this and that variables. You have to name things and to organize and structure the data that you have to analyze, understand, and make sense of. And then you have to make a method to solve the problem by some tests, some loops, and you have to use functions or objects and things like that. That is to say, structures inside the not only the data, but as well the process. That's automatization. And then there is debugging. And debugging is more than just understanding where there are problems. It's analyzing systematically some steps, okay, and being able to think logically and to predict what are the outcomes at different steps. That's what is debugging. Okay, so for example, if you try to solve a mathematical problem and you say, okay, let's take x is equal to 5, for example, you're doing some kind of debugging. Okay, that is to say, you in a specific instance, what is the outcome of the process I'm looking at? This is debugging. Okay, and these 6 general competencies make this notion of computational thinking. And it's way more than just thinking like a computer. And how shall we teach that? Okay, well, when we teach that, actually, we have as well side effects. That is to say, the students, they gain confidence in dealing with complex problems. They gain persistence in working with difficult problems and with ambiguous problems. Okay, they get more tolerant for ambiguity because the problem that you have at hand might be a little bit ambiguous at first. And as well, you might not, usually when we teach mathematics, we give them problems where we know the solution of the problem. And we fake the fact that we don't know. Please explain me in more details, but we actually know the solution. And usually with this computational thinking, we might not know the solution. It's an open-ended problem. And so that's usually what appears when we teach problems that deal with, especially in project-oriented teaching, okay? And this way you have as well to work usually as a team, because we decompose the problem in sub-problems. So you have to communicate with one another to achieve a common solution. Okay, so there are some good side effects on trying to deal with computational thinking. Okay, so there is no magic wand to teach computational thinking, but we have developed a tool which is called Colette. Okay, and this it's a two-sided tool. Okay, there is an app for the students where they can actually go to and work with the app. So I don't know if we will have time, so maybe we'll come back to that if we have time. But there are some examples that you can work with on your cell phone, just flashing this code, this QR code, which is here, and we're actually using augmented reality in order to visualize the production of the algorithm that we work with. Okay, so for example, here we have. Okay, let's sorry. So for example, one of these tasks is to go to this tower here, and you have a little drone here. You see, it's a virtual drone, but this is an augmented reality. Okay, so we just use the cell phone above this sticker where there is this city logo. Okay, and pops up the scenery, and then this little drone, which is just there here. Okay, you have to pilot it through an algorithm for it to take pictures of these little pictures that we have on this tower. So you have to make an helix around this tower and turn around it and make snapshots. Okay, and so you can see here that this drone has made 2 snapshots and is processing the 3rd one. Okay, so it's moving in 3 dimensions, and actually you can turn around this CT logo in order for you to have a look on the other side. Okay, so in augmented reality, so it's pretty nice. And so here you can see the path that this drone has done. Okay, so this is the kind of task that we have under this QR code, and that we might have the time or not, depending on what you will tell me or not. Okay, and the answer from the side of the students on the student view is some kind of block programming this way. Okay, you initialize the drone, and then you count from 1 to 10, and you fly this many steps and you turn to the left and etc. Okay, this is the kind of block programming that are solutions of some of the tasks that are in this process. Okay, and so here you can see a picture of a student holding a tablet, because it works not only on Android but as well on Mac and on iOS. Okay, and so you can turn around the logo in order for you to see different things. Okay, well, okay, so if you have time well, I'm going to continue with the talk, and we'll see whether we have time to do that. Okay, so there is the app. This is the student's view, and then there is a web portal for the teachers in order to arrange the different learning path, okay, and to arrange the different tasks which are given to the students, okay, and this is how things are done on the web portal. On the web portal, training module has this kind of form, okay, so you have a snapshot of what is to be done, okay, and you can and as I said, this is the app is available on Google Play and on iOS. Okay, and the way you do that in the classroom is you have what we call a digital classroom. That is today, during a certain period of time, the students can join a learning path, and you can actually interact with the students by sending messages to them and wherever they are. And then you can see which task they are working on, and maybe sending them messages to unblock them so that they can continue, or maybe give some feedbacks on how they've done. So there is a path here that we might have the time to go through. So the path has some code like that, P9835, and that's then the student has to enter that in this plus button here, okay, and they plus here, and they put the number of the path here, and then you sorry, I put the French version, I should have switched to the English one. Okay, so you just add a learning path with a code, okay, and this is the kind of thing that you have. So there are 9 tasks here, and then you can begin it. So you have one task after the other, and you have to on your smartphone you have to program, okay, and then you can verify. Okay, you see the verification here. On the verification button, then you can use this AR view in order to see whether the discrepancy between, for example, here we can see that the student had to do an arc, okay, a strange arc like this, and he just made a cube, okay, in the middle of it. Okay, so well, that's the first start. Okay, not having the right answer at first is no problem. Okay, that's the way to go. Okay, so that's one way to do what to teach in a world of data. Well, you have to teach computational thinking. Okay, and this is way more than thinking like a computer. Okay, and you have to see algorithm a little bit like an art form. Okay, because you might have different tasks which are fulfilled by different algorithms. Okay, or different algorithm can be implemented in different ways. Okay, sometimes you have things which can be in this or that order. It doesn't matter. It's a matter of taste. Okay, and actually art and computational thinking is as well something that I really like, because okay, we say that eventually all these kind of things are supposed to solve problems. Okay, we are problem solvers, aren't we? So whether we are engineers or mathematicians or what, so but usually in order to do that we have to model the world around us. But the actual physical world is way too complicated. Okay, the equations that govern from the point of view of the mathematician or physicist the world are very complex. Okay, and so you cannot ask students to model this complexity. Instead, you can ask them to model much more modest things, such as cultural objects. For example, art, which are art produced by an algorithm. Okay, so there is a current in contemporary art which is called op art. Okay, actually it dates back from the 50s. Okay, more than 50 years ago. So, but nevertheless, they had this idea that the art in the time of replicability, okay, where we can now for cheap replicate some things. Okay, what is really art is just the idea. Okay, and not the actual frame, painted frame. A painted frame in itself is not much. Okay, what is to be valued is the idea behind that. Okay, so they did, for example, exhibition which were telephone exhibition. That is to say, the artist didn't go there and they didn't send any art. They just phoned to a painter who did exactly what he was told to do. And this is the kind of thing that we had. Okay, and so as for me, this kind of art form, they are really begging for me to be understood. Okay, what do you see here? Okay, so you see discs on squares. Okay, and these discs on squares are arranged by lines and rows. Okay, so each line and row, that's two integer numbers. Okay, and to these two integer numbers, you have one color for the disk and one color for the square. That is to say, you have a functional relationship between I and j, the coordinates of one cell, the type of object that you have, whether disk or square, and the color. And these colors are actually just integers as well, because you can see that there are 1, 2, 3, 14 colors, 14 different colors. And you can see that the disk colors are the same along these diagonals. Okay, they are the same along these diagonals. No, sorry, that diagonal. Well, these are the squares. The square are in this direction, while the disk are the same in that direction. Okay, that is to say, one depends on the sum of the two I and j coordinates, while the other depends on the difference between the two coordinates. Okay, and this kind of exercise for students to actually come up with an algorithm that duplicates this sort of art form is very fruitful in computational thinking. Okay, another from Julio Leparc, where you can see here sectors, gray and white sectors, circular sectors, and you can see that as well they depend on the coordinates I and j, and well, you can cook up the way they depend on the coordinates, okay, in a mathematical way. Here is an American artist which is called Sol Lewitt, and here you can see that you could not model things in a totally predictable way. What you can predict is a certain probability from two colors to have the third color in a given set. Okay, so you can see that modeling a situation is not might not be totally predictable. Okay, so but it's okay. You have your probability is a way to handle the world around us. Okay, so this is Sol Lewitt, and so the modeling. So modeling, we do that as well on the streets. Okay, so we had another project, which was called Math City Map. Okay, and Math City Map is a tool, a handheld tool on a smartphone, where you put actually tasks on geolocalized tasks. So it's a bit the same idea as Colette, but what you have in front of you are tasks where you have to model things and answer some questions. Okay, so well, I think I'm going to stop here. Una, if how much time do I have?
You can show this practice to us. We have
okay. So maybe then I'm going to show you things on how things look like on okay, but I don't have the connection. That's the thing I was trying to set up when we actually started. Sorry. Okay, so okay. Just a moment. So I'm launching the app on my cell phone so that you can see how it looks like on the cell phone. Here it is. Okay. Okay. So I'm going to share my screen actually. Okay. Zoom. Okay. That's the one. Okay. Do you see my screen? Okay.
Yes.
Okay. So so the here you see the Colette app. Okay, so I could use the plus thing here to put. Okay, maybe I should change to the English version. Sorry, let me change it to the English version. No, that's not the one. Okay, English. So sorry, there is no. Okay, so there is nothing. There is it's in German, but not in Mongolian. Okay. So what did I say? I said P. I don't remember. Okay. What was the number I was talking about? It was okay.
It was P5.
It was P9835. Okay, P9835. Okay, P9835. Okay. And then I add it. Okay. Oh, says I cannot find it. Ah, okay. So I don't know what I did wrong. Let me go to the actual task that I had in store. Okay, so you can see the different tasks which are here, and I just click on it in order to see the task description, which is in French. Okay, so you have a corner with a size of 7, and you start at x is equal 7, 7, 3. Okay, so then you can arrange the blocks. Okay, in from here. So I have to repeat. Well, let me show. I have to show the picture of the solution. That's the thing I have to do. Okay, so I have 3 in a row in a L configuration. Okay, so I have to repeat 3 times because there are 3 levels. Okay, Well, but actually I don't have just to repeat. I have to name that. So this is going to the trash. Okay. Control. And I from 1 to 3. Okay. And what shall I do? I shall what I should do is I should put some cubes, but here as well I have to count another time. Okay, so I have to have two loops, one inside the other. Okay, from J to 1 to 3 as well. Okay, so okay, I just do these kind of things, and then okay, let's see, let's put some cube. I'm going to set blocks. So this is going to be not to be good, okay, because this is not going to answer exactly the problem. Okay, I have some variables. I have to put the variable I here. Oops, that's not what I wanted to do. Okay, I is here. Okay, and y is equal to 1. Okay, this is equal to j, because I have the variable. Well, maybe I is going to be the altitude. Okay, and the variable is going to be I. Okay, let's. I'm just doing this. Okay, and I can see what it is doing. And oops. And here I have to oh, see here you don't see my screen any longer. Oh, that's the first time I tried that, so I cannot. When I in artificial augmented reality, you cannot see what's happening on my screen. Ah, too bad. Okay, so that's I didn't check. That's so I'm actually seeing the result on my screen, but you cannot see it. Okay, so
we cannot see.
Okay, so I think I'm going to stop here, and just to give you some hints of this very nice project. There is a nice project, Colette, on computational thinking. So I urge you to scan this. This is not the app. Okay, this here is not the app. It's actually some exercises that you can use on your smartphone without installing anything. It's working in the web browser, and it allows you to test this augmented reality vision. Thank you very much for your interest. I'm finished now.
Can you hear me?
Yes.
So I see that there were some questions by Unmay Shigupta.
Yeah.
Are the 6 processes necessary for all type of computational thinking? Or does it differ from one type to another based on the problem? Of course, we don't use the full-fledged computational thinking in all of problems. So maybe some problems are more algorithmic thinking, some are more debugging, but we try when teaching to address different kinds of competencies that concur to this computational thinking.
Okay.
Thank you for the question.
So then, can you hear me, Krishna?
Yes.
Yeah. So then I have a question. I remember that you showed to us how you are using this city map application with your students in your campus. But the seems you developed new tool, and it looks similar to apps, like it is the program instead. And okay, for me, interesting. If I think that I'm your student and I need to learn mathematical thinking, that I have to be good in mathematics, but suddenly coming this kind of tools, and I need to somehow learn this tool and understand this tool. It does take a lot of time, and maybe students became unmotivated, and maybe focus can be moved from most important things to this understand application and program. Have you some kind of similar cases also?
Yeah, I see what you mean. So it's true that learning a new tool is always a little bit time consuming, but as for, so it might be the case with Colette, because I mean, block programming is costly, okay? It is not so very efficient on a small screen, but as for Math City Map, this is really pretty much straightforward. I mean, we have pupils from grade 3-4, which already know how to use that. Okay, so this is Math City Map here, and you have to have a list of different trails. Okay, so here is a trail that I'm going to. So I just download the trail, okay, and then I can see a map of where I'm standing, and these different tasks which are associated with little pins, and I click on the pin, and for example here insects. You have a hotel insect, so there is a hotel of insects, and I want to know how many rooms there are in this hotel of insects. So it's just a matter of multiplying. So it's a very basic multiplication, and so we are as well in the process of having a text-to-speech tool which would read out loud the text. So that even students of grade 2 can actually use it. So, well, I think the UI is pretty easy for that one. But of course, it's not the case of Colette, which is a little bit more involved. Yes.
Okay. So any more questions? If not, thank you very much, Christian. That was really a big support from morning to until evening. We are sitting with us online together and supporting our symposium. In the meantime, I those session I need to want to present. There's the two ladies sitting. Maybe you come up.
We can front.
I talked to you about Tashkent University from Uzbekistan. And we here have two professors from this university. They personally come to symposium. That maybe if you will be tomorrow, come to us online after tomorrow. These ladies can discuss with you because they want to invite you to Tashkent and this kind of things. What you are teaching, the new methodologies and things that will be very interesting for them. So this is the two ladies, which is very much interested to invite best professors from Europe to Uzbekistan. So, and we trying to organize this learner-centered learning seminar. If you remember, we're doing it one time every 3 years. That we trying to organize it in next year March in Tashkent by this lady. So it will be 3 days and discuss the other things. So, okay, Christian, that was really good support for us. Thank you very much. Do you have any question to us or the comments to us?
Thank you very much. Thank you for your interest.
And thank you and have a good evening. So, okay, then yeah, we have completed the session. Most important for me is the evaluation for today's presentation.
Will deliver today directly?
No. You will give it after all presentations. But if you leave, you can leave me. But who's staying, we really have to do it. Yeah. So this means thank you, Christian. So, yeah. Okay, this means now we are on the
So goodbye.
Yeah,